Hey, good afternoon. Assalamualaikum. Yesterday we stopped at here. Trapezoidal rule for single application. Okay. So today let's try for multiple application trapezoidal rules. Have you tried on your own? Right. Okay, we try for trapezoidal multiple application. Let's try for n equals to 4. For C, now we will do for C. Focus on n equals to 4. Okay, we know that A is 0, B is pi over 2. This is your range, the given range, from 0 to pi over 2. So using trapezoidal rules with 4 segments, n equals to 4. First thing first, you need to find what is your h. Okay, how to find the h? B minus A over n, right? N is the order. So sub in all the values. What you get? What you get for your h? Correct, 0.3927. This is your h. Then after you obtain your h, then you need to arrange your data. What is the axis, the f-axis? Remember, this h is the step size. The one that you need to use when you want to find your new axis. Okay, n equals to 4. Meaning that you will have 5 data points. X2, X3, X4. Okay, so find out what is your axis first. The range is between x0 will be 0 and x4, the last point will be pi over 2. Okay, that is your only range. Then after that, you find what is your f-axis. Fx, this is the function of the fx. Okay, using this function. x1 here, what is the number of x1? Okay, let me clarify again the function of the h. H is the step size. Step size is the one that you need to know in order for you to find the points. Okay, so step size, here is the step size, the h. Step size should be the same. Okay, please ignore the size, the shape of this. H should be the same for each. Okay, so how to find your new point? X1 is x naught plus h. You will get x1. Okay, xi plus 1, xi plus h. So if you want to find x1, your x naught plus the h, then you will get your value. The A and B, okay, the A and B is the range given. The range, okay, from here A to here B. So your x naught is your A, x4 is your B. The final point. Okay, so here your x1 will be 0.3927. Okay, try to calculate your x and fx. Fx first. Make sure you get the correct number as mine. Mode radian. Use the mode radian. fx1, what you get? Is it 11.6955? Right. This number is wrong. Maybe this one I calculate using degree. Is it the same as yours or different? Okay, so once you obtain all the values, the data, then sub into the integration equation for multiple application. This one, trapezoidal multiple application. Remember the intermediate part multiplied by 2. Okay, this part, this part. So this part meaning that from your data, fx, it involves this range of fx. Okay, first point and last point should stand alone. These intermediate values, summation, then multiply by 2. You get 16.51. Okay, if you use degree, you will get somewhere 18 point something. Final answer for n equals to 4. This one. Let me know if you stuck anywhere. Rabia, are you okay? 12.5. The axis and f-axis correct. Okay, Tasmia, get it? Okay, now I move to, okay, here I am to explain on the difference between having one segment and four segment. Okay, this is the curve for the function 8 plus 4 cos x. Okay, this is the exact curve. Okay, so just now the range is between 0 to pi over 2. So pi over 2 is here. Okay, now for the first one, we use single application. The range is from 0 to pi over 2. Single application trapezoidal. So you only have one segment between this point, trapezoidal. Okay, so this is the calculated area for single segment. Okay, but if you have the second one is 4 segment, right? 4 segments. Next one is the 4 segment. So 4 segment in between 0 to pi over 2. 4 smaller segments. So you will have smaller error compared to the one segment just now. Okay, so that's why the more segment that you have, the least error that you get. Okay. Now try to find out what is the actual value for this integration pi over 2 from 0 to pi over 2 for this function. What is the true value? 16.56. Right. Okay, we go back to the first integration where single application. Okay, this is for single application 15.7, whereby when 4 segment, you get 16.51. So using smaller segments, it is approaching to the true value. Okay, we reduce the error. Okay, now that one is trapezoidal. Okay, straight away we go to the final exam question. The function is much more complicated. Okay, we try this. It asks you to compute the approximation of integral below function. So this whole thing is your fx. Okay, and d, we use it as 4. Okay, you can replace d as 4. Now it asks you to find the integration using trapezoidal rule with n equals to 9. Okay, what is the first step to do? Find the step size. Yeah. Okay, find the step size. The h. B minus a over n. What is your b? 9, correct. Here, this is the b. This is your a. The range that you should cover. So b is 9 minus 1 over 9. What you get for the h? 0.889. Okay. Now I use 3 decimal points. Up to you. Usually, I will advise students to use 3 to 4 decimal points. Okay. Then step 2. Arrange the data. Find the x and f axis. We have 9 segments. So how many points that you should have? 10, correct. So you have a lot of data over here. Calculate your x-axis and your f-axis. Remember, your range is between 1 and 9. So first point is 1, last point is 9. They find the axis in between and also the f-axis. Remember, use radian. This one, something wrong with my data. Correct. The data up to 9, N9, not N10. That's where. Okay, so the last point will be 9 at N equals to 9. Okay, you get the same? The integration value, do you get the same as mine or slightly different? This one. 633. Then how to know your answer is correct? Find the true value. Then only you know whether your answer is in the range or not. Okay, for the range, it is based on what is given. A is 1, B is 9. So some questions start from 0. Some questions start from A is 0, A is 1. Okay, so that what I want to highlight here is X not necessary to be 0. It depends to the range given. Okay. You can see most of you get the correct answer. Any question for trapezoidal? Yeah. So there are equations to use whether it is single application or multiple application. The equation will be given, no worries. Okay. Can I move to the next topic? Okay. Yeah. Anis, dapat dah? Okay. Now I want to move to Simpson's rule. Similar approach, but they are using different equation. Simpson's rules is using starting with second order. Simpson's rule apply second order onwards. Okay, so second order means it needs 3 data points. N equals to 2 with 3 points. If n equals to 1, Simpson's rule 1/3 doesn't apply. Okay, so similar to trapezoid, we need the point. We want to find the area under the curve. Okay, check for A first. This one is Simpson 1/3 rule. For Simpson 1/3 rule, it takes area under a parabola connecting 3 points. Okay, for Simpson's 1/3, minimally 3 points, it requires to have the parabolic area under the curve. Okay, so this area under the curve. Trapezoid just now, we take the trapezoid shape. That's why we use the trapezoid area formula. Okay, for Simpson's 1/3, it takes parabolic area under the curve. And then you see the error is the place where it doesn't cover. Okay. Another Simpson rule is 3/8. 3/8. Okay, 3/8. Minimally, it needs n equals to 3, which 4 points. Okay, I explain the difference first. Later we go one by one. Now for B over here, it is 3/8 rules. It needs 4 data points, minimum 4 data points. Okay, it takes the parabolic, no, not parabolic, cubic. cubic equation connecting 4 points. Okay, so you can see the area under the curve covered by 3/8 and 1/3. There are difference. Okay, in comparison with trapezoid, totally different shape. Okay, now that's the concept of the Simpson's rule. 1/3 and 3/8. There are two conditions. 1/3 minimum n equals to 2. It needs 3 points. Okay. Now, one similar. Okay, this is the equation for 1/3 rule. Simpson 1/3 rule. 6 over here is 2. Sorry. 6 over here. Wait. H is b minus a over n. Okay. See here, 3, right? So here, the 6 here comes from 2 multiplied by 3. 3 is from here just now. 3. Where this 2 comes from is the n. N equals to 2. This one for single application. Okay, single application. N equals to 2. Yeah, understand the equation? Now, the error, this is to find the error which involve the differentiation of 2 times. Okay, but I will not focus much on this kind of error equation. Okay, we just use the ET, which is the true value minus the approximate value. Okay, much more simpler. Okay, now, to make you understand further, we try this example. It asks you to use Simpson 1/3 to find this integration. This is the given function. Okay, so your A is 0.1, B is 1.3. So this is the only range. Simpson 1/3 rule, single application. So single application means n equals to 2. Okay, it doesn't give you the n. Okay, if the question doesn't give you the n, you can assume a single application, which n equals to 2. Okay. Now, first step is always to find the h from the data given, sub into the value, sub into the equation. (0.6). Okay. Then arrange your data. N equals to 2. So you have 3 points. Your axis and your f-axis. First point x naught is 0.1 because the given range start from 0.1. Last point should be 1.3. So the intermediate is 0.7. Okay. Now find out your f-axis. I'll share you the answer. Check your answer whether same as mine. Once you obtain all the data, subs into the equation of Simpson's 1/3 rule. But get Arina? 8689. Okay, Tasmia? Rabia, do you get it? Okay, that one is for single application, 1/3. Now we move to multiple application, 1/3, still 1/3, multiple application. So this is the equation. Equation will be given. You just need to know which for which. Okay, so for multiple, it involves few application of the singles. Okay, so meaning that you need to include this part. This is the intermediate part. Okay, see here, I want to highlight 4 multiplied by summation of the 1, 3, 5, the odd numbers, the odd data points. Okay, let's say you have n equals to 6. So you will have 7 points, right? So you will have x0 up to x6. Okay, fx0 for the first x0. Okay, this one I for odd. Let me do it fx. Okay, I don't want you to confuse. So fx. 4 multiply the summation of the odd fx value. So the odd one will be 1, 3, 5. Okay, then these values multiply by 4. Plus, this part is the summation of even numbers. So even here, it involves only 2 and 4. Why 6 is not included? For this part, it involves 2 and 4 only. Should we include 6 or not? No, because 6 is the final point, xn, final fxn. So this fx6 is the fxn, the final point. Okay, up to that. Then divide by 3n. 3n. N depends on the segment. Okay. Okay. Then for this equation, the odd segment and the even segments, you need to separate them. Okay, let's try this example of multiple Simpson 1/3. Let me know if I go too fast. Okay, you just stop me. No issue. Now, this example using the same function as in trapezoid last time. It asks you to use n equals to 4 to estimate the integration of this function from a0 to b 0.8. That is your range. Simpson 1/3. Okay, we check the correct equation first. This is the correct equation. Simpson 1/3. First step, what is your h? Okay, find out your h. So 0.8 minus 0/4. You will get 0.2. Okay, next step, arrange the data. Ruben, what is x1? What should be the value for x1? How to get the x1, Ruben? 0 plus h. 0 here means the previous value. Okay, x0 plus h, 0.2. So x1 will be 0.2. How about x2? What is the number, Ruben? 0.4, correct. Okay, so 0.4 plus 0.2 will be 0.6. What do you get, Tasmia? Right. 1.6235. Okay, so much more closer to the true value. You can compare, we can compare back the value using trapezoid method last time. Single and multiple. Okay, for the equation fx naught and fxn, separate them first. First point, last point. Okay, then only you classify which one to use for odd and even. Okay, odd from here, from this value only, this data only. So for odd, we will take 1 and 3, odd value. So even value over here only have 1, which is fx2. Okay, so only have 1 value for even. Okay, so I'll stop at this example. Tomorrow, I will continue on the 3-8. Okay, let me know if you are stuck somewhere or you still don't understand. Okay, so that's all. Thank you.